My name is Tiarnan Doherty. I work on a class of semiconductor materials called metal halide perovskites. Semiconductors are really material that is the basic building block of pretty much all electronics that we use today. Specifically, the perovskites that I work on, I develop them for sustainable energy applications, so make things like solar cells out of them. And I also work on developing them for medical X-ray imaging. What I do is I try and understand where performance losses and stability issues come from in these perovskite materials so that we can hopefully get past those issues and get them out into the real world. I use electrons and X-rays to basically bombard the material and see if there's anything interesting about the structure or composition that might kind of tell us something about why they degrade under operation. The techniques I use, they're really powerful, but they generate an enormous amount of information and it's impossible to analyze manually. So what I'd like to do during the Schmidt Fellowship is see how some of these great innovations in AI and data science can be applied to some of the microscopy techniques that I use so that we can accelerate some of the insight that we get. Compared to other more traditional semiconductors, they're interesting because we can make them in a lot of kind of unique ways. They're very cheap to make, they're easy to make, they're made of earth-abundant elements, so we can make lots of them without worrying about running out of the constituent elements. I want to help get material science innovations from the lab into the real world.